Coefficient of performance in refrigeration and air conditioning. Introduction. The coefficient of performance COP is a simple way to measure how good a cooling or heating system works. Think of it like a score that tells us how much cooling we get for the electricity we use. As people use more energy around the world and worry about the environment, it becomes very important to understand COP. A good COP means the system uses less electricity to do the same job, which saves money and helps the planet. COP is different from other efficiency measures because it can be higher than 1. This happens because these systems move heat from one place to another. For example, your refrigerator moves heat from inside to outside your kitchen. This video will explain what COP is, how to calculate it, what affects it, and show real examples of how it works in everyday life. Theory, explanation. What is COP and why is it important? COP stands for coefficient of performance. It is a number that shows how well a cooling or heating system works. The higher the number, the better the system. COP compares how much cooling or heating we get from the electricity the system uses. This is important because it helps us choose the best systems and save money on electricity bills. How to calculate COP. For cooling systems like air conditioners and refrigerators, we calculate COP like this. COP for cooling equals heat removed divided by electricity used. For heating systems like heat pumps, we calculate it this way. COP for heating equals heat delivered divided by electricity used. The heat removed or delivered is measured in the same units as the electricity used, so COP has no units, it's just a number. The best possible COP. Scientists have figured out the best possible COP using something called the Carnot cycle. This gives us the highest COP that any system can achieve. The formula is best possible COP equals cold temperature divided by hot temperature minus cold temperature. The temperatures must be measured in Kelvin. Real systems never reach this perfect number, but it helps us understand how good our systems could be. What COP numbers mean? When we see a COP number, here's what it means. COP of 1 means we get 1 unit of cooling for every 1 unit of electricity. COP of 3 means we get 3 units of cooling for every 1 unit of electricity. COP of 5 means we get 5 units of cooling for every 1 unit of electricity. Higher numbers are always better because we get more cooling or heating for the same amount of electricity. What COP measures? COP measures how well a system works at one specific moment with specific conditions. This is different from other measures that look at performance over a whole season, such as SER, seasonal energy. Efficiency ratio. COP is useful for comparing different systems when they work under the same conditions. What makes COP higher or lower? Several things affect how high or low the COP will be. Temperature difference. When there's a big difference between the cooling or heating area and the external area, the COP goes down. For example, an air conditioner works harder, lower COP, on a very hot day compared to a mild day. System design. Better designed systems have higher COP. This includes having a good compressor, accurately sized heat exchangers, and the right refrigerant. Working conditions. COP changes based on how hard the system is working, the outside temperature, and how well the system is maintained. Medium used. Using water as a cooling medium can improve COP compared to air due to better thermal conductivity. Practical examples. Let's look at a regular refrigerator in your kitchen. The inside temperature is about 4 degrees Celsius or 39 degrees Fahrenheit, and the kitchen temperature is about 27 degrees Celsius or 81 degrees Fahrenheit. For a Carnot refrigerator, best possible COP equals T-low divided by T-high minus T-low. Let's add the values to the equation. Best possible COP equals 277 divided by 300 minus 277 equals 277 divided by 23 equals about 12. This means the perfect refrigerator could remove 12 units of heat for every 1 unit of electricity. But real refrigerators don't work this well because nothing is perfect. Real refrigerators usually have a COP between 2 and 4, so your refrigerator removes 2 to 4 units of heat from your food for every 1 unit of electricity it uses. This is still very good because you get much more cooling than the electricity you pay for now. Let us look at an air conditioner that keeps your house at 25 degrees Celsius. When it's 35 degrees Celsius outside, the perfect system would have best possible COP equals T low divided by T high minus T low. Now we will add the values to the equation. Best possible COP equals 298 divided by 308 minus 298 equals 298 divided by 10 equals about 30. This very high number shows why air conditioners work well when the temperature difference isn't too big. Real air conditioners usually have a COP between 3.5 and 5. This means for every 1 unit of electricity your air conditioner uses, it removes 3.5 to 5 units of heat from your house. Good modern air conditioners with COP of 5 are much better than old ones and can save you a lot of money on electricity bills. Large buildings and factories use big chillers to keep things cool. Let's say a chiller removes 500 kilowatts of heat from a factory process and uses 125 kilowatts of electricity. COP equals QL divided by W equals 500 divided by 125 equals 4. This COP of 4 means the chiller moves 4 times more heat than the electricity it uses. This is very important for factories because cooling costs can be a big part of their electricity bill. A high COP means they save money and use less energy, which is good for the environment too. Heat pumps are special because they can heat your house by taking heat from outside air, even when it's cold outside. Let us say a heat pump puts 10 kilowatts of heat into a house and uses 2.5 kilowatts of electricity. COP equals QH divided by W equals 10 divided by 2.5 equals 4. This COP of 4 shows why heat pumps are much better than electric heaters. An electric heater can only give you 1 unit of heat for every 1 unit of electricity. But the heat pump gives you 4 units of heat for every 1 unit of electricity. This makes heat pumps a smart choice for heating homes and buildings because they save money and energy. Conclusion. The coefficient of performance COP is a simple but important way to measure how well cooling and heating systems work. It shows us how much cooling or heating we get compared to the electricity we use. Higher COP numbers mean better systems that save money and help the environment. The examples show that COP helps us choose the best systems, from home refrigerators to big factory chillers. As energy costs go up and we care more about the environment, understanding and improving COP becomes more important for making better cooling and heating systems for the future.